Okay, so today's solving trig equations. We're going to see some stuff that hopefully you have on your note card already. Again, start that at your earliest convenience. That will probably not be until, we're going to spend 3 days just on this one section, so I probably won't be until day 3. Okay, so I'm going to start us off pretty basic. I don't really have a lot of notes. I think we should know how to do this already. All of us having taken Algebra 1 and Algebra 2 and Pre-Calc A, and making it so this far through trigonometry. So my goal is to find all the solutions. I want to know what t can be so that sine of t equals 1/2. I don't want to know the inverse of it. Now you can go ahead and tell me the inverse if you want. Pi over 6, right? So according to Elijah, t could equal pi over 6. I agree. What else? 30 degrees, which is pi over 6, yeah. Since we went ahead and started with radians, we'll stick. But if you want to put 30 degrees on this, Madeline, you can. 2 pi over 12. Okay, you're just telling me the same angle there. 5 pi over 6, right? What happens if I take sine of 5 pi over 6? There's no domain restriction on these, all right? So yeah, what else? 9 pi over 6, that's 3 pi over 2. Sine of 3 pi over 2 is -1. Cool. Negative pi over 6, absolutely. Negative pi over 6. What else? Negative. No, negative pi over 6 doesn't work. Huh? 7 pi over 6 is -1/2. Same as negative pi over 6. Sorry. What else? 11 pi over 6 same as negative pi over 6, which is -1/2. We're done. Yeah, we're done. Sure, yes. Sine of 0 is 0. 1. -1 pi over 6. -11 pi over 6. Yes. If I take sine of -11 pi over 6, that gives me 1/2. What else? -7 pi over 6. Absolutely. That is coterminal with the 5 pi over 6, so it has to work. What else? 13 pi over 6. Yeah. If I take sine of 13 pi over 6, that gives me 1/2. What else? 17 pi over 6. 25 pi over 6. 25 pi over 6. Absolutely. It's infinite number. There are so many solutions. Remember, that sine curve just sat there and oscillated between -1 and 1, right? So every time that thing hits 1/2, boom, a solution. It comes down, it's a solution. So it keeps going on forever and ever. So we need a shortcut on this. So what I want you to do on this is I want you to tell me the two that are on your note card. That's going to be on your unit circle, which are the two first ones you gave me. The most obvious ones are the ones that are between 0 and 2 pi. So pi over 6 and 5 pi over 6. Now, how in the what kind of voodoo magic were you working to get these right here? You added 12 pi over 6. Can you reduce that for me? 2 pi. All you were sitting there was just simply telling me coterminal angles going around, right? Every time you told me pi over 6 was an answer, and it was. But every time you go around, that's an answer, right? Each time. So what you're going to tell me is you're just going to say plus 2n pi, where n is just a number. Okay, so I could plug in 1 into that, and I could add 2 pi. I could plug in 2 in for n, and I'm adding 4 pi. I'm just adding those revolutions all the way around. All right, and just do it for both of them. Plus 2n pi. So unless you just want to list every answer on these, you just simply just throw in a plus 2n pi at the end of it. I would just plug in a -1 in for my n. Really, at the end of this, you're supposed to say n is an element of the of the integers. So either it's in the box, but n is any integer. So integers are all the whole numbers and their opposites. So you can definitely plug in negative numbers in for n as well. As I look at my unit circle, oops. I looked at my unit circle, and right there was the point, negative square root of 3 over 2, comma, 1 half. Also, we're in the stripper quadrant, and we have a reference angle of pi over 6. And so it has to take on the same value, positive 1 half. No, that would be if I asked you to do t equals sine inverse of 1 half. We'll get to that. We'll talk about that soon. Everybody okay? 7 examples? We gotta go faster than this. So, challenge accepted. All right, so here's what we're going to be doing on these types of problems. Okay, I got it broken down into 3 steps. First, look for a pattern. I'm going to tell you, I'm probably not going to put one on your quiz when you come back Tuesday that is going to say, hey, cosine of t equals 1, solve. I'm going to make it so you have to sprinkle in a little bit of pre-calc A or algebra 2, all right? And we'll kind of see that as we go, all right? There will be factoring with this. You guys are factoring geniuses, though. I don't think that's going to hold us back. Huh? Off Monday, yes. Solve the equation the same way you would solve an algebraic equation. Instead of solving for x, though, you're going to solve it for the trig function. So you're going to get it all the way down to where you see a sine of t on one side, a cosine of t, a tangent of x, or whatever we're solving for. Once we get there, we're going to solve for the angle just like we did. All right. I'm still wanting to solve for x. I'm still wanting to solve for theta, but I'm going to have one extra step at the end where I'm going to have to look to my unit circle or my sine, cosine, tangent table, whatever you're using on your note card. Hopefully it's just right there in your head because we went through all 4 of those pop quizzes. So here we go. Okay, now we'll talk about, don't worry about this right now, I'll come back to it in just a minute. My goal is to solve this down for cosine theta. My goal is to get it all the way down to theta. But before I do that, I want to get it all the way down to just cosine theta. Okay, so what needs to happen first to make it so the cosine theta is the only thing on the left side of the equation? Add 3 to both sides. I agree. So A3 right there, that's going to mean add 3 to both sides. So that's going to cancel this negative 3 and give me an, thank goodness that was negative. Like that's going to be a problem. Add 3, what does that give me? Negative 2, thank you. All right. And now divide by 2. Okay, so that's going to cancel this 2 on the left side, making it so the coefficient is a 1. Negative 2 divided by 2 is negative 1. Now we just have a problem that's from the last slide. So where's cosine theta equal negative 1 at? (180 degrees). Now look, I definitely want my answers in radians on this one, right? So pi, where else? 3 pi, where else? 5 pi, where else? Plus 5, but here's what this wants. This says only give your answer between 0 and 2 pi. So you don't have to worry about the plus 2 and pi on this. Okay, that will come and go. You'll see it both ways. All right, so I call this one on the interval 0 to 2 pi. So it doesn't want any answers bigger than 2 pi and no answers smaller than 0. So I don't have to worry about all those different values that we put on there last time. Yeah, always, hopefully in here. Great. All right, you and your pod squad, you guys pull out those whiteboards and you guys work this one together on that whiteboard. Once you get it, flash it up. I'm going to give you a yay or nay. If you're watching the video, let's try this one on your own. There's 2 equals.
How does that work?
Well, obviously 1 equals 0, so now this should definitely be a -1. My bad. All right, so it looks like everyone's getting it down to here, and I would have to disagree with it. Did you take the square root of both sides? Oh, plus or minus, right? Square root method makes it so I have to put a plus or minus on there. So tell me, where is sine theta equal to either the square root of 2 or negative square root of 2? Pi over 4, I agree. 3 pi over 4. It's still positive square root of 2 over 2. Yeah. Every pi over 4 is going to work on there between 0 and 2 pi. That make sense? No? Where'd I lose you at? Huh? Add 1. Divide by 2. Take the square root of both sides. You get square root of 2 over 2. You can still do pi, for me, you can still do pi over 4 plus 2 n pi, 3 pi over 4 plus 2 n pi, all the way through. Or you can do pi over 4 plus, it would be 1/2 n pi. Because that's where sine theta is equal to negative square root of 2 over 2. Yeah. So if you get a plus or minus on there, that's great news. You don't have to worry about the all strippers take cash. You just go grab pi over 4 out of every quadrant. Or pi over 6 out of every quadrant. We'll do some more of those. All right, here we go. I'll leave the squared out of this one. What makes this problem potentially harder than the last one? So it's secant, big deal. Why does the secant make it harder than what we've been doing? It's the thing. It's not on our table. We're not used to working with secant, right? The 3 basic ones that we've been quizzing a lot on and seeing a lot is sine, cosine, and tangent. So can I change this? All right. So I'm just gonna do the reciprocal of both sides. What's the reciprocal of secant? Cosine. What's the reciprocal of -2? That's a little bit easier now, right? You want to do it on the interval or off? On the interval? Okay. Oh. All right, so where does cosine equal -1/2 at? Second and third quadrant. Okay, good. So let's use that. We need to grab something out of the second quadrant and out of the third quadrant. Because cosine is negative. All right. So it's first and second? No. Second and third. Okay. So in the second quadrant, the only thing that's positive is sine. All right. I'm wanting something negative. The third quadrant, the only thing that's positive is tangent. I'm wanting something negative. Fourth quadrant, cosine's positive. So there's no way that this came out of the fourth quadrant because it had a negative value. So where am I at in the second quadrant? 2 pi over 3? I agree. And then where am I at in the third quadrant? 4 pi over 3. Well, we got 3 more examples? No. I took the reciprocal of both sides. So I raised, yeah, that's algebraic. I raised both sides to the negative first power. So whatever I do to one side, I can have to do on the other. Yep. Oh. Oh. I'm going to skip this one for now. You need to cut it. All right, let's do this one. Are we going to go back? Yeah. So let's first on this one. Distribute the 2. Get rid of the parentheses on there. That's kind of a downer on this problem. So 2 tangent of x plus 6 equals 5 plus tangent of x. Okay. Subtract tangent x. Okay, so what will that give me? Okay. Tangent x plus 6 equals 5. Subtract 6. I agree. Subtract 6. I'm going to leave this one on the open interval. All right. So there's no 0 to 2 pi on this. So where does tangent x equal negative 1 at? Pi over 4. Second quadrant. Yes. 3 pi over 4. Not bad. And then tangent's also negative in the fourth quadrant, right? What has pi over 4 in the fourth quadrant? And so if I'm on the interval 0 to 2 pi, those are my answers. I'm going to say this one's not on the interval because the directions didn't say it. So I'm just going to put a plus 2 in pi on both of these. Okay. Now tangent does have a specific quality about it that you're going to see the answers look a little bit different maybe in the key. But I assure you I will accept these answers. Okay. We'll just say plus n pi on tangent. Because tangent's period's only pi. One more? I don't think so. Not today. I want to get you guys some time to work on these. I haven't been good about practice time in class. Put in the calculator. What are you going to put in the calculator? Why are we using the calculator on this one? So on your quiz Tuesday, I've already got it started, a calculator page and a non-calculator page. Because I think that you should know that sine inverse of negative 1/2 is negative pi over 6, and not just be able to key that into the calculator and get that. So I already tried that. All right, so this one's not one of my nice cosine values, right? Negative 2/10 is not on my unit circle, right? Or not one, it's not something that we labeled. All right, so how are we going to find it? So I guess set a calculator, you're exactly right. Tell me what you're typing in the calculator. Parentheses negative 0.2. Cosine of negative 0.2. Add it to the other side. So this helps. I don't think that helped us. It's a good idea. Getting a set equal to 0, that's going to help on a lot of these, but on this one, I don't think it got us. Divide it by 2 over 2. Well, that would be 1, and then we'd still be back to right here. Divide by negative 0.2. Divide by negative 0.2. That's going to be cosine theta. Move the hat. Nothing has a hat. Huh? Negative 0.2 over 1. So that's going to give me negative 0.2 over cosine theta equals 1. Let's try cosine inverse. I'm looking for an angle here, right? I know I heard you over there, but anyway. So cosine. So you said move the hat. All right, so. Oh, okay. All right. So you're saying that I'm just going to move the cosine over. Now notice, number one wrong thing. Someone's going to do this. One of you 15 in here is going to do this. Is you're going to, I'll just divide both sides by cosine. That is not cosine times theta, all right? That is one thing altogether. So cosine is switching sides, or think of it this way. I'm taking cosine inverse of both sides. And so that is a cancellation right there, okay? So what does this give me right here? 1.77? I agree. Wait a minute. Sure. 1.77. Everybody get 1.77? 1.77 what? What's the units? Radians. Yeah, just read off the rest of it. But man, I've gotten 2 answers on everything today except for one. I got 4 on that. I got 4 on the different one. Add 2 pi. That'll give me something bigger than 2 pi. Add pi to it. If I am not on, sometimes whenever I am on the axis, I'll either get 1 or 2 answers. If I'm at pi over 2, or not pi over 2. If this was 0 or 1, if my answers are pi over 2, pi 3, pi over 2, I'll either get 0, 1, or 2 answers on that. But if I am inside one of the quadrants, I should get 2 answers on that. Because where is cosine of an angle negative? Where is cosine negative at? Second and third quadrant. Okay. What quadrant is this 1.77 in? Second? 1.77. What value is this up here? This is pi over 2, and this is what? Pi. What is pi? 3.14. Okay, so it's not in the third quadrant, right? So it is less than 3.14. And this is, let's see, half of that would be 1.57. So this had to come from the second quadrant, right? So remember, cosine inverse, whenever I type that in my calculator, it has a domain restriction on there. It's only going to give me an answer between 0 and pi. I want all the answers that's between 0 and 2 pi. So how am I going to get the angle that is in? You're exactly right. It's in this third quadrant right here where take is positive. Double it. So 1.77 was very close to right here. Everyone agree? I was this far from the axis, the x-axis. So let's just go the other way that far. So subtract it from 2 pi. Let's just do 2 pi minus. I know this distance right here is 1.77. Let's just subtract 1.77, and it will put it in that third quadrant. Notice I'm doing stuff off the x-axis, never the y. I'm just doing reference angles, except for my reference angles are bigger than 90 degrees now. 4.54. So that's how they're going to get their second answer. You're going to have to play with that some. I probably didn't teach that just real well, but you playing with it and you practicing these when you get to them in the practice problems will help you. Okay. Think about what quadrant you're in. Have your note card handy with the all strippers take cash, and know what quadrant you're looking for answers, and that will go a long way with this. Okay. Do we need to do this one? We good? We're good. You are. You're good. So you got 6, 7, 8 problems. All right. You should be able to knock out more than half of those in class today.